In this video, I'm going to explain how to differentiate the inverse of a trigonometric function and also how to find the derivative of one function not with respect to x but with respect to another function. So first of all, let us differentiate this one, sine inverse of cos x with respect to x. So here, what will be the solution of 1? So first step, what you need to do, you take y is equal to sine inverse of cos x. Then sin y will be equal to cos x. Name this as equation 1. So differentiating 1, with respect to x, we have, now what is differentiation of sin y? It will be cos y. Now differentiation of, since it is with respect to x, so it will be cos y into the differentiation of y with respect to x. So you will get here on the left hand side, it will become cos y into dy dx. And on the right hand side, what is differentiation of cos x? It is minus sin x. So we'll get it as minus sin x. Now next, what we need to do is transfer this one cos y to the right hand side. So it will become minus sin x by cos y. But we want it in terms of y. So this can be written as minus sin x. What is the relation between cos y and sin y? It is square root of 1 minus sin square y. We know that square root of 1 minus sin square y is equal to cos y. But we have from equation 1, what is sin y? It is cos x. So you can replace this sin y by cos x. So it will become 1 minus cos square x. So this implies that dy dx is equal to minus sin x divided by square root of 1 minus cos square x. You can write from equation 1. So this will imply that dy dx is equal to minus sin x divided by, now what is square root of 1 minus cos square x? It is again sin x. So you can replace it by that 1 sin x. Now this and this will be cancelled. So finally we have got the derivative of the function dy dx of y is equal to sine inverse of x as minus 1. So this will be the solution of 1. Next, let us differentiate that one, tan inverse of 1 minus cos x by sin x. Number 2, you take y is equal to tan inverse of 1 minus cos x by sin x. So here what you can do now, before you differentiate, let us simplify this term inside the bracket. So this one can be written as what? As y is equal to tan inverse of, what is 1 minus cos x in terms of sin square x? It is 2 sin square x by 2 divided by sin x. Okay, you note down this one, since 1 minus cos x is equal to 2 sin square x by 2. And one more thing you can do, you can substitute this sin x. Sin x can be written as sine of 2 into x by 2. And what is the formula of sine 2 theta? It is 2 sin theta cos theta. But here theta is equal to x by 2. So it can be written as 2 sin x by 2 into cos x by 2. So for the denominator sin x also, you can replace it by this value. Then in that case, you'll have this one, y is equal to tan inverse of 2 sin square x by 2 will remain as it is, and the denominator you replace it by 2 sin x by 2 cos x by 2. Now 2 and 2 can be cancelled, and 1 sin x by 2 also can be cancelled. So this will imply that y is equal to sin x upon 2 divided by cos x upon 2. Now which is of the form, okay, there is a mistake out here in the last equation. Can cancel this one. can write this tan inverse. Okay, tan inverse should be there. So this implies that y is equal to tan inverse. Now what is the term inside the bracket? It is equal to sine x by 2 upon cos x by 2, which is same as tan x by 2. So you get here as tan x by 2. Now tan inverse and tan can cancel. So finally you get y is equal to x by 2. So differentiating this one, let me name this as equation star. Differentiating star with respect to x, we have dy dx is equal to what? What is differentiation of x? It is 1, and since half is there, so it will become 1 by 2. So therefore, finally, what is the differentiation of that function? Y is equal to tan inverse of 1 minus cos x by sin x. You see that we first simplify the term inside this bracket, and then finally we got the value of y as just x upon 2. Then on differentiating this, you get it as half. So this implies that d dx of tan inverse of 1 minus cos x by sin x is equal to half. So I hope it is clear now how to differentiate this inverse of a trigonometric function. Without substitution also, the value of 1 minus cos x by sin x, you can directly differentiate it by transfer first this tan inverse to this side. Then you get tan y is equal to 1 minus cos x by sin x. And then on differentiating this one, then you have to apply the quotient rule of differentiation in order to integrate it. But here I'm using the method of substitution for the term inside the bracket so that we can easily differentiate it in a few steps only. Now let me come to the next one, that is differentiate of derivative of, how to find the derivative of one function with respect to another function. Derivative of one function with respect to another function. Number 1, find the derivative of let us take in this case the derivative of x to the power x with respect to x log x. So now you see that in this case we have to find the derivative of x to the power x, not with respect to x but with respect to x log x. So what we need to do now for this type of derivative, what the first step you need to do is you take u is equal to x to the power x and v is equal to that second function x log x. Name this as equation 1 and this as equation 2. So now next step what you need to do is for the first one, from equation 1, what you have to do is taking log on both sides. Taking log on both sides of 1, we have log u is equal to log of x to the power x, which is same thing as x log x. By using the property of logarithm, log of m to the power n is n log m. Okay. So this implies that log u is equal to x log x. Name this as equation 3. So now after getting this log u as x log x and in equation 3, and from 2 we have v is equal to x log x, what we need to do now is let us differentiate now this 3 with respect to x. Differentiating 3 with respect to x, we have, what is differentiation of log u? It will be 1 by u, since it is with respect to x, so du dx, and then this will be equal to differentiation of x log x. So you can apply the product rule, so it will be x into d dx of log x plus log x into the differentiation of the first function, that is x. So this implies that 1 by u du dx is equal to x by x plus log x, or du dx is equal to u times of x, and x can be cancelled, so you'll get 1, so it will be 1 plus log x, and you can replace the value of u by what? What is u from equation 1? It is x to the power x. So this will imply that du dx is equal to x to the power x into 1 plus log x. Name this as equation 4. You can write from 1 u is equal to x to the power x. Now next, differentiate that equation 2 with respect to x. What is equation 2? Equation 2 is v is equal to x log x. So on differentiating 2 with respect to x, let us see what we can have now. Next, you differentiate 2 with respect to x. We have dv dx is equal to, again use the product rule, it is x log x, so it will be x into d dx of log x plus log x into d dx of x. So this implies that dv dx is equal to x by x, since differentiation of log x is 1 by x, plus log x into 1, as differentiation of x with respect to x is 1. So these two can be cancelled, so you get dv dx is equal to 1 plus log x. Now let us name this as equation 5. But our aim here is to differentiate the given function, this one, of x to the power x with respect to x log x, by taking u to be this one, v to be this one. That means you have to differentiate u with respect to v. So that means you have to find out du dv. So therefore, du dv is equal to what? It is du dx divided by dv dx. And from equation 4, what is du dx? It is x to the power x into 1 plus log x divided by dv dx. From equation 5, it is 1 plus log x. So this and this can be cancelled. You can write from 4 and 5. So finally, what is du dx or du dv? The differentiation of that x to the power x with respect to x log x is equal to x to the power x. Okay, I'll do one more problem related to this derivative of one function with respect to another function, so that will be more clear. Number 2, find the derivative of, or we can write this in this way, differentiate cos inverse of theta with respect to log of 1 plus theta. So let us differentiate cos inverse of theta with respect to log of theta. So like in the first problem, so you can take this one, u is equal to cos theta, or cos inverse of theta, and v is equal to log of 1 plus theta. Name this as equation 2, this as equation 1. Now from 1, cos u will be equal to theta. So name this as equation 3. So let us differentiate separately this one, differentiating 3 with respect to theta. We have, what is differentiation of cos u? It will be minus sin u into the differentiation of u with respect to theta. So on the right hand side, differentiation of this one, theta will be equal to 1. So it will be 1, and this implies that du d theta is equal to minus 1 by sin u. But sin in terms of cos, it will be minus 1 by square root of 1 minus cos square u. And this implies that du d theta is equal to minus 1 by, what is cos u from equation 3? It is theta. So it will be minus 1 by square root of 1 minus theta square. You can write from 3. So name this as equation 4. Now next you differentiate this 2 with respect to theta. So differentiating b with respect to theta, that is differentiating 2 on differentiating 2 with respect to theta, we have dv d theta. Differentiation of log of 1 plus theta will be 1 by 1 plus theta into the differentiation of 1 plus theta inside the log function. So it will be differentiation of 1 will be 0, differentiation of theta will be 1. So you get just 1 upon 1 plus theta. So name this as equation 5. Therefore, the differentiation of cos inverse of theta with respect to log of 1 plus theta will be given by du dv. But du dv can be written as du d theta with respect upon dv d theta. Du d theta from equation 4 gives you what? It will be minus 1 by square root of 1 minus theta square divided by 1 upon 1 plus theta. And this is called minus 1 plus theta. This 1 plus theta will come to the numerator, and this square root of 1 minus theta square will be in the denominator. So divided by, you can split this one, it is of the form a minus b, or a square minus b square, which can be written as a minus b into a plus b. So it will be 1 minus theta into 1 plus theta. And this is called minus 1 plus theta divided by square root of 1 minus theta into square root of 1 plus theta. So this can be cancelled, and then here, if you cancel this one, then the power of this will be half. So finally, let us see what will be the differentiation of cos inverse of theta with respect to log of 1 plus theta. It will be equal to minus 1 plus theta under the square root divided by square root of 1 minus theta, which is the same thing as minus square root of 1 plus theta by 1 minus theta. So this is the differentiation of cos inverse of theta with respect to log of 1 plus theta. Okay, I'll do one more problem here. Differentiate sine x square with respect to x square. Okay, so same thing, what you need to do is to take u is equal to sine x square, name it as equation 1, and v is equal to x square as equation 2. So what you need to do, you differentiate this u with respect to x, differentiate v with respect to x separately, and then after that you can find out what is du dv. So here let us see. So differentiating 1 with respect to x, we have du dx is equal to cos x square, as differentiation of sine is cos, into the differentiation of the term inside the sine function. It will be 2x. So this implies that du dx is equal to 2x cos x square, named as equation 3. And next, differentiating 2 with respect to x, we have dv dx is equal to, what is dv dx? It is equal to x square. Now it will be 2x. So this is equation 4. So now let us see what will be the differentiation of sine x square with respect to x square. Therefore, du dv will give you the derivative of sine x square with respect to x square. So it will be du dx upon dv dx. So this is equal to, what will be the derivative of this? It will be from equation 3 and 4. Du dx gives you twice x cos x square divided by dv dx from equation 4 is 2x. So this and this can be cancelled. So finally the derivative of sine x square du with respect to x square du dx is equal to cos of x square. So hope it is clear now how to differentiate the, one function with respect to another function, and also how to differentiate the inverse of trigonometric function.